feasibility studies and academic consultancies undertaken through our project. The project supports collaboration between 7 Scottish universities and small to medium-sized enterprises in Scotland to develop and test innovations for sustainable building design and refurbishment. The project is funded by European Regional Development Fund and Scottish Government CIC program, which is now managed by Scottish Funding Council. This is a live event, so if we have a fire alarm, we will have to stop, but you can always watch video recording of this webinar in due course. Our webinar presentations will finish around 1:30, and then we will have a Q&A session until 2 o'clock. But our online viewers can start using chat facility to ask questions at any point during the webinar, and they will be answered in Q&A session. So the title of today's webinar is Reduction and Eradication of Fuel Poverty via Renewable Energy Technologies. This was a study that was undertaken by Edinburgh Napier University and Solas Scotland Ltd. And our speakers today are Professor Tariq Muneer of Edinburgh Napier University and Graham McLennan of Solas Scotland Ltd. So I would kindly ask now Graham to start with his presentation.
Thank you. Good afternoon, everybody. Thanks for joining us. Thanks, Branka. On behalf of Solas Scotland, I'd first of all like to thank CIC Start Online and Branka for the opportunity to undertake this piece of work. It's been fantastic to have the opportunity to work with Professor Muneer of Tariq, and it's been very, very interesting to date in terms of where we've come to. I've been asked to say a few words about Solas Scotland, or the Solas Group. As you can see there, there's a little diagram of what we are. I'll then talk a little bit more detail in terms of what we do, and in particular encompass within the social enterprise model, which is something that we wanted to explore as part of this piece of work, in terms of the viability of this model to offer community benefit through renewable technologies, as Branka says, in particular solar PV within Scotland. I'll then introduce a few questions and a few suggestions in relation to how, in particular, the solar PV market is developing in Scotland from our perspective jointly, and after that I'll pass over to Tariq, who knows a hell of a lot more about solar PV than I do, and we'll talk in great detail about the technicalities and how we might develop. So firstly, Solas Scotland, as you can see, is a registered charity. I know from those who are online just now that I can see a lot of familiar names, and a lot of people will know this already, so apologies if I'm covering old ground. We've been operating now for 25 years this year, so we're having a kind of celebration, although it's with mixed feelings, because we exist to primarily help eradicate fuel poverty in Scotland, so it's with mixed feelings to say that we're celebrating 25 years, and as everyone or most people will know, fuel poverty is increasing markedly, despite all of our good work over many years in Scotland. We have 7 wholly owned operating subsidiaries, so Solas Scotland's a registered charity, and the subsidiaries are all listed there. Solas Insulation, Solas Assist, Solas Utility Initiative. We've got Solas Energy Saving Services Limited and Solas Property, and also Good Egg Energy, which is the most recent addition to our offering as an organisation or a group of organisations trying to eradicate fuel poverty. In particular, we want to concentrate today on Solas Renewable Energy. That's a relatively new addition to Solas. We've predominantly been involved in the insulation market for the last 25 years, and we still are quite heavily, and we welcome the opportunity to do that, but we're always exploring new angles as we try to up the ante on eradicating fuel poverty. And solar PV, now that we're fully MCS accredited, is an area that we are involved in heavily, and touch wood, we are going to become more and more involved in as we move forward. And to reiterate, we are proud to be a social enterprise, and anyone that knows me knows that I say that every 10 minutes, even when I'm sleeping. Social enterprise for us at Solas is the model that we believe can make huge inroads into the eradication of fuel poverty in our case, but also can lead to sustainable economic development across Scotland more and more. And from what I can see through our membership of Social Enterprise Scotland and working within the social economy in Scotland, I believe Scotland's leading the way, and we can continue to push the boundaries of social enterprise. The key being that whilst we are viable businesses and we deliver quality and service and capacity and capability, that 100% of our profit is reinvested back into delivering social good through our charitable parent Solas Scotland. So, just very briefly, Solas Scotland's mission is to deliver long-term sustainable improvements to the lives of our customers, our clients and our colleagues. And some of our objectives as we move through a 5-year strategy of diversification and growth is we are quite ambitious. As I said earlier, we want to play a part in Scotland leading the way in the development of the social economy and services within the market under that model. We want to have, we believe we do have world-leading products and services, and the Solas way at the heart of what we do and how we do it. What that means is the social enterprise way, our iteration of the social enterprise way, the way that we treat our colleagues, our customers, our clients, the way we do business, the way we make decisions. We believe, and something I'm very proud of as Managing Director, is that we do things a little bit differently, and hopefully anyone that's worked with Solas will feel that. We've developed over the last 25 years by investing in long-term partnerships, and we see our position in terms of the solar PV market in Scotland as continuing to go along those lines. We are not in it for short-term profit. We're not here today, gone tomorrow. We're here for the long term. It's very important to Solas that the partnerships we have with our clients, key stakeholders, the government, local government, the Scottish Federation of Housing Associations, the Scottish Council of Voluntary Organisations, Napier University, Glasgow Caledonian University, etc., is a long-term partnership, and that actually drives the way that we do things and the decisions that we make and the things that we do in order to perpetuate that. And we want to be seen as an employer and a partner of choice. We want, when we advertise jobs, and we are recruiting just now, that people will apply because they feel that they want to work for Solas. And even in the solar PV marketplace, we're now beginning to see already that many people are coming to Solas as their partner of choice in helping them to develop and deliver their solar PV solutions to aid their own objectives as organisations, or in fact as individuals. Many people are choosing Solas. So that's good. There's lots of other stuff, but I won't go into that just now in terms of our objectives. Very briefly, and obviously you'll be able to get copies of these slides, so we won't go into this in great detail. I've mentioned already that we reinvest 100% of our profit. So to put that into simple terms, as a limited company, Solas Renewable Energy aims to be profitable. Any profit, any net profit that's generated through our activities at Solas Renewable Energy Limited is reinvested and gift-aided tax-free back to Solas Scotland, and then reinvested back in to services to aid Solas Scotland achieving its objectives of generating and creating and sustaining high-quality employment in Scotland, as well as eradicating fuel poverty. We currently employ 59 people. We've got bases in Dumbarton and Greenock. And as I mentioned before, we continue to diversify in energy markets, and we're recruiting at present. We do plan to relocate into bigger, better, more energy efficient premises over the next 18 months. You can see there a list of products. I've mentioned them all already. I won't go into them again in any detail, but essentially our aim is to help businesses and organisations and individuals to save energy and money. To give an idea of scale, we've insulated about 150,000 houses in our history, and we continue to play a decent sized role in the Scottish insulation market, which is being supported by a number of stakeholders, not least the Scottish Government, particularly through the Universal Home Insulation Scheme just now in the Energy Assistance Package, and we welcome that. and welcome the opportunity to continue to work with the Scottish Government and other key stakeholders in terms of our charitable objective of eradicating fuel poverty. We, alongside a number of other organisations, particularly the WISE Group and Changeworks, fellow social enterprises, Solas delivers face-to-face home energy advocacy services and advice, currently in the region of about 5,000 vulnerable clients per annum. We really want to up the ante on that. Energy Action Scotland have recently evaluated some of our services, and we can see that the leverage in terms of the investment in those services to the ratio of pounds back in the pockets of fuel-poor households is quite significant, and Energy Action Scotland have managed to help us to demonstrate that independently, that that's the case. And we believe, and I believe that the Fuel Poverty Forum believes, based on the report of last week, that there should be further investment in these energy advocacy services, which is energy advice plus. It's advising householders and keeping them right, but actually fighting their battles alongside them and holding their hand and educating and leaving a legacy where they can then deal with their energy issues domestically themselves. We are one of the leading providers of EPCs in Scotland. Our turnover in this financial year will be in the region of 3.5 million, and our intention over the next 4 years, 3 to 5 it says there, is to create at least 40 new jobs in the green sector, as some people call it, and to be generating a turnover in excess of 10 million. So you can see there that we do plan to grow, and we want to work with key stakeholders to actually put in place what government policy is suggesting, that there's lots of high quality employment available here as Scotland continues to lead the way in the fuel poverty, energy efficiency and sustainability markets. We want to play a big part in that as Solas. And as you can pick up already, we are serious about eradicating fuel poverty, and we believe fuel poverty can and will be eradicated. Oops, that went the wrong way there. So, in terms of the Kickstart brief, what we wanted to do was to explore, along with Napier University, the fact that community benefit potentially can be delivered through solar PV in Scotland. And community benefit is very much at the heart, as you can tell, of what Solas does. It's not to benefit our shareholders, because we don't have any. It's not to benefit our owners, because we don't have any. We're a charity at parent, and it's to benefit our objectives as an organisation to help eradicate fuel poverty. But many other aspects of community benefit we will explore, and Tariq will talk a little bit about that in terms of the triple bottom line, the triple E benefits that can be derived. Can we reinvest the profits that can be generated through installing solar PV back into communities in a wider scale? Can we help organisations like housing associations who are charged with providing high quality, warm, dry, affordable homes to their customers or tenants, many of whom, in fact most of whom, if not all of whom, are charities at parent? Can we find a model that if housing associations are going to invest in solar PV, that the feed-in tariff, generation fee, that's generated by the owners of the systems, namely the housing associations, is best reinvested back into the objectives of those organisations? Can we create a situation where we do generate a net income for these organisations that can then be used in as best a way as possible? And we've explored that as part of this piece of work. In short, we believe, and we believe we can demonstrate that that's absolutely the case. What about the emerging market in the short, medium and long futures on solar PV in Scotland? We wanted to explore that, and Tariq will say a little bit about that. There's obviously been major changes, and I'm sure I don't need to tell the people who are participating today what those changes have been in the recent times. The changes to feed-in tariffs, significant cuts in generation fee feed-in tariff, further plans to do so, the removal of a confidence within the market, to the point where I think it would be safe to say that there's been significant reductions in the levels of solar PV installations across Scotland in the last 5 or 6 months. Is that going to change? If so, how and why and when? we've explored that. We've seen that, in particular, in our view, we feel that, in fact, it can be demonstrated that clearly there's been a huge change in the generation fee feed-in tariff, and that the return on investment for anyone that's investing in solar PV has been markedly changed as a result of that. But with our clients at present, in the commercial sector and the domestic sector, there's still a significant interest in solar PV. There are still people investing in solar PV despite the changes. There will be further change in feed-in tariff, as most people know, I'm sure, who are watching today, on the 1st of August. In the domestic sector, I believe they're going down to in the region of 16 pence. That's changed from 42 pence 6 months ago. Big changes. But we're working with our clients to look and see whether or not there's still a viable return on investment based on that. And there is. And we intend to continue to work alongside our clients and our partners to inject the confidence back into the market. As well as that, we see that, in fact, we're told that there's an expectation that electricity prices will go up. The last I heard was a projection of 20% increase in the next 12 months. As electricity prices continue to go up, the viability of solar PV will continue to increase. And if we think about the medium to long term here, and I'm saying maybe 3 to 5, possibly up to 10 or 15, 20 years, we believe at Solas that there will come a point where the feed-in tariffs will actually become less and less of a factor in terms of investment decisions. It's about security of supply. It's about saving money by generating your own electricity, as much as looking for a return on your investment. And obviously Tariq will speak as well about the reduction in cost, the reduction in material prices, the supply chain differences that have been driven in recent years, and particularly in recent times. The fact that technologies are improving all the time, to the point where, you know, there's a balance here, and we believe at Solas, and will continue to invest in solar PV. And we do have some exciting developments over the next few weeks and months, which I can't talk about publicly today. But we're really quite excited about some of the moves that are happening within the Scottish market in terms of investment in solar PV, and we're delighted to be involved, and really privileged to be involved in that. And if you watch this space over the next few weeks and months, I'm hoping that you'll be able to see really good examples of what we're talking about today. But the key for us is that if social enterprise can deliver on volume, quality and price, and continue to develop Solas and others to meet the demand, which we believe will rise in the short, medium and long term in solar PV and other renewable technologies, that the key is keeping the money in. It's where does the profit go? When an individual householder invests in solar PV, when a housing association or the NHS or a council invests in solar PV, where does the profit go? What is the level of profit being generated by the organisations that are installing the solar PV? And what do they do with that profit? Because, as I've publicly stated, and everybody knows, certainly those that are listening today, and anyone that knows about Solas knows that every penny of net profit that we generate, and there are a growing number of organisations like us in Scotland and across the world, every penny of that profit is regenerated back into services. It's keeping the money in. That is the difference between a viable business model and not moving forward. And I would urge, and I hope that this piece of work that Tariq is helping us with will demonstrate another facet of social enterprise, really changing the way that we do business in Scotland for the better and for the benefit of our community. So is Scotland ready to be a world leader in solar PV and in the emerging social enterprise business model? I believe we already are, and I believe that, in fact, I know that Solas absolutely wants to continue to deliver on that. And I think it's probably a good opportunity now to pass over to Tariq, who can take us through some more stuff in relation to the technology and the technicalities of solar PV in Scotland. Thanks.
Thank you very much, Graham. I found that introduction very, very appropriate, and also very focused on the work we have done along with you. And I must thank you for giving us the custom to carry out this we call this kind of design studies, and also to Branca for running the Kickstart program, Edinburgh Napier University is one of the 7 universities that is part of Kickstart, which has run very successfully over the past number of years. And it has, I believe, completed 70 such studies and a large number of webinars and other outputs. So without further ado, I'd like to take you through the present job which we have completed for Solas. Our brief was that Solas is engaged in installation of solar PV modules and systems over the entire Scotland. So they did not want a particular design tables or design graphs or plots for a given location. They wanted a general set of design aids, let's say, or design guide for Scottish locations in general term. So that's what we have tried to do. We have taken the length and breadth of Scotland by defining the range of latitudes and longitudes. We have obtained the weather data from the NASA website, long-term weather data, and using that weather data, we have tried to produce a guide for installers such as Solas to find out at the very early design stage what sort of module area would be needed and what would be the optimum orientation and tilt angle of the sloping modules to deliver maximum performance in a number of locations in Scotland. So as I say, we have produced tables for a range of latitudes and longitudes so that if a desired location is in between a range of latitude, they can interpolate and get their answers. So that was the main scope of the study that we have done. I might also like to refer to you an earlier PV design study we have done for a Perth-based housing association, Fairfield Housing Association, where the job was for a particular property. So we looked into the shading issues and those sort of aspects. And that study was done in collaboration with the Mackintosh School of Architecture. So if you are interested, you may also want to get details of that webinar or that report from Kickstart offices. So if I now move to my first slide, this slide is showing what, in a sense, what Graham has been saying, that despite the government's lack of impetus or lack of serious effort to promote PV, as you know, historically, UK was one of the last countries within Europe, Western Europe, to introduce the feed-in tariff. And then within a few months, they have retracted from that 43.3 pence per kilowatt hour for domestic properties, and they had dropped to 21 pence per kilowatt hour. And as Graham was saying, from August, it will drop further to 16 pence. So roughly 1/3 of what was an offer up to the end of last year. But despite that, we see that in Scotland and elsewhere, there is a lot of PV activity. A lot of manufacturers have appeared on the scene, very, very large manufacturers. Manufacturers are producing gigawatt capacities each year from their plants. And that is because the price has fallen roughly 80 to 90% from 1985. If you see the price drop, it has been quite a spectacular price drop. And I believe this price drop will continue further as the German bankers are forecasting that by 2016, the PV electricity will compete directly with fossil fuel electricity. And I believe it will happen. So just to give you an example, in year 2005, in April 2005, I installed a 15 kilowatt facility at Napier University. And it is the experience of this past 7 years is that there are no problems with this technology because there are no moving parts. The only issue is of cleaning the modules. But the rain in Scotland is a very benign factor, and in effect the panels are self-cleaning if they're mounted at an appropriate angle, and hence it is a self-sustaining technology, and we have been seeing no reduction in output in the past 7 years. So the price-wise, the cost of the system then was £7 per watt, and now that price is dropping to something of the order of £2 per watt. So that's a very, very significant drop. The module price used to be, a rule of thumb was 70% of the system cost was module price, and the system would typically be the module, the inverter, the cables, the framing structure, and so on. But now, because the module price has gone down so dramatically, it is now only 60% rather than 70% of the cost, and it will continue to fall in proportion. So I believe by 2016 it will approach the cost of fossil fuel electricity, and that will be very good news. Next, I'd like to present to you information of top 10 manufacturers in the world, just to give you an idea of the production capacity of these plants. Suntech is the world's #1 producer now, based in China, and they are producing close to 2 gigawatt capacity of modules per year. So this will give you an idea of which countries are active and which manufacturers are among the top 10. I'm presenting this with a purpose. Towards the end of my presentation, I'll discuss what are the economical ways to get PV modules at a very competitive rate. So we will discuss this in view of this production capacities. Now, there is a lot of activity, as I said, and production cost. And recently I came across this American manufacturer, which is giving a high-grade module, which is offering high-grade module at a very competitive price, $1.85 per watt. So in pounds, it will convert, the system cost will convert to less than £2 per watt, as I was saying earlier on. Remember I said 7 years ago it was £7, and now it is under £2 per watt for the entire system. Moreover, other manufacturers seems to be topping at about 240 watt per module capacity. This manufacturer is offering 400 watt modules. There is also news in the industry that there are 1 kilowatt modules under discussion, and they'll be released perhaps in a year's time. And they also come with a built-in inverter. So you got an AC power producing module of 1 kilowatt capacity. Now that will be very, very good news. Another advantage of this manufacturer was they produce a double glass encapsulated modules. So this is ideal for desert-like locations. Say, for example, you are in southern Spain. The climate is very, very amenable to solar capture, and yet the dust storms, they are a particular problem for PV modules. But by having a double glass encapsulation, they've eliminated the dust storm related problems. So there is solution now for every problem that you may face. Now I'd like to talk to you about a very important issue, which is the shading issue. Unlike other technologies, and unlike even solar thermal technologies, whereby you may have solar thermal collectors to heat your water or heat your space, the solar PV technology has this inherent disadvantage in a way that it is susceptible to large shift in the power production, even if only a fraction of the module was under shade. So what I'm showing here are the IV, that is the current voltage curves, for a module which has 36 cells. This is a slightly older generation of modules, Now you can get modules with 72 or even 96 cells. So here what's shown is the power output of a 36 fully illuminated solar module, and that's what you expect under full sun conditions. But if only one cell out of 36 was under shade, the output will drop in this manner, which is a very, very sharp drop. So shading issues should be considered very carefully at the design stage. And one way around it is to look at the neighboring trees, whether the trees could be pruned, and the module should be installed not willy-nilly, as you see for some traffic, charging points. They are put very small PV modules. They are almost always in shade. So there's no point having PV modules on those devices. You should have the PV modules on the highest point in the building, and be very aware of this phenomena which I'm showing here, that you should try to maintain a shade-free kind of environment. Another disadvantage which is not very apparent, one thing which is apparent is the loss of power, which is quite dramatic as I'm showing. But there's another issue here. When a cell is under shade, that branch of the module will get overheated because a lot of current is trying to, current produced by other cells is trying to go through the shaded part of the module. And this overheating will create local hotspots. In some cases, even the module may fail completely, which will be a long-term damage rather than just loss of power. So this item is very careful. This should be considered very carefully at the early design stage. So this is a good example. This building which you see here had all these modules installed, and a few months later, a high-rise building appeared next door. I don't know how the planning approval was provided, whether there was some objection from the present building owners or not. But anyway, what you see here is almost half of the modules are under shade, and hence there will be serious loss of power. In such a system, it's better to have a number of inverters. So inverters which will be for modules which are shaded some of the time, and inverters which are shade-free almost all the time, so that they don't have this overheating problem that I was talking about earlier on. So this is something to watch for. Now let me take you through what are the design stages of calculation of energy that will be delivered by PV modules. So I've tried to put this in a flow diagram here. First of all, you'll get the basic data which is available now, as I say, from satellites. So the NASA-based website, which is clearly indicated in our report, so that link can be provided to you. That will provide to you the global monthly average radiation on horizontal plane. Now, remember that the modules will be, if possible, tilted. They'll be inclined to get maximum energy output. But the data is available. The data available is on a horizontal plane. So how do we shift from the horizontal to the tilted plane? We will discuss that. So the data available is global energy, then diffuse energy coming from the clouds and the rest of the sky other than sun. So the global energy minus diffuse energy will be the beam energy coming from the sun's disk. Then you will have the timestamp, and then you'll have the temperature data. So the NASA website will provide you the dry bulb, wet bulb temperature, and other parameters such as wind speed and so on. You will also need the location details. So you need the latitude, the longitude of the location. You'll need to ascertain what will be the tilt angle you'll have. This will depend upon the existing roof, or if you may want to create a structure specifically at the desired angle. What will be the orientation of the roof, the aspect angle is it called. Then what is the neighboring ground like? If, for example, if there's a forest in front of you, it will have a very low reflectivity because the trees will absorb all the radiation. On the other hand, if you have a tarmacking, you can have up to a quarter of the energy falling on the neighboring ground will be reflected back on the modules. So in snow, for example, you will have 90% reflection, which is very beneficial for the solar production. So all this information plus the manufacturer's data you need. By that I mean the current voltage curves, which I showed you in the previous slide. You must have access to that. You must also have access to what will be the loss of power as the temperature of the modules starts to rise, and that's provided by the manufacturer. Once you have all that information, most softwares which are available commercially, or you may want to calculate yourself using tools which are available in various books. You will calculate the amount of radiation arriving on the module, then what will be the cell temperature, and that will be obtained by a heat transfer analysis. Because you know how much energy is coming on the surface, what is the air temperature, so you will be able to work out the cell temperature. And then you will be able to use the manufacturer's data to find what will be the voltage and current at the maximum power point. The inverters are very clever devices, and they will operate in a manner such that for any given radiation and any given cell temperature, the delivery is at the maximum power point. So you will know the voltage and current at that point, and then you will be able to find the power output. Okay. So I think I have covered this topic, so I'll move to the next slide. So what I'm showing here is for one given location in Scotland where we have performed study, we are reporting here what will be the daily energy output for each of the 12 months if 42 Scott modules, and this is a German manufacturer, they produce good quality modules of 240 watt each capacity. So if 42 of those modules were used, and the total module area was 70.3 meters square, in the first year of installation, it produced something like 10,000 kilowatt hour, which is quite a substantial amount of energy. And the profile of month-to-month variation is shown in this slide. So the procedure I described in the previous slide, if you follow that, using the data which is freely available from NASA, you will be able to work out very, very quickly. You'll be able to work out what will be the production profile, such as shown here. So to follow further, in the previous slide I've shown the daily total energy produced, but one wants to know what will be the hourly profile. So that is shown here. The software can give you answer to these sort of questions as well. If we are working in solar time, that is sun time, then you will have a symmetry about noon. So you will have the energy delivered at say 11.5 hours will be the same as 13.5 hours. Hence, the afternoon hours are not shown, only the forenoon hours are shown. So I'm showing for 5 hours here what will be the production in kilowatt hour, hourly production for all the 12 months for the same site, one site in Scotland. So for Solas, what we have done is we have taken, as I say, the range of the latitudes and longitudes in which Scotland, the landmass of Scotland lies. We have not gone to the further islands, but rather concentrated on the mainland, so to say. So using this Google map, I'm showing you the range of the geographical latitude and longitude here. One question which arises from a number of people who are interested in this technology is that, will I ever get back the energy that is embedded or invested in the PV modules or PV systems? So to answer that, I'm providing this slide here. So let me just read out the main points of this slide. the life cycle audit, as it is called. So you take into account how much energy went into the production of the PV modules, the PV inverters, the cables, the frame, which will take the modules, etc., etc. You also add to it the cost of transportation. So, for example, at Napier University, the modules came from BP solar plant in Madrid. So we took into account the shipping cost, meaning how much energy was used in transporting by ship those modules to the site in Edinburgh. How much CO2 was released in that transportation. So we take into account 3 E's. We call this the 3E approach, a triple E approach. The first E is economics, that is cash flows of money. The second one is how much energy was used in the production and transportation. And the third E is environment, meaning carbon dioxide and other acid rain gases. So by taking account of the 3 E's, you have performed a holistic study. So what this slide is giving us is that the payback time, energy payback time, is called EPBT, of a PV system installed in southern Europe is 1.2 to 1.8 years. Obviously, this figure will change with the amount of energy you get from the sun. So it is location dependent. In Central Europe, it will be around 1.5 years. If you go to very sunny climates like Saudi Arabia, then it will be only under 1 year. Now for Scotland, we have performed this audit for Edinburgh, and we found the energy payback period was between 5 and 8 years. This entirely depends on the framework also. So that's what we found, and we found this figure to be in close proximity to Japanese researchers' work. So there's an article which was published in Institution Mechanical Engineers Journal, and upon request an article can be sent to you. So if you take the life of the modules as something between 20 to 25 years, even in Scotland, the module will pay back 3 times over in terms of energy embodied in the system. This slide is covering something which Graham has already covered, so I'm not going to go into detail. There have been a lot of anger among the PV solar installers regarding the government cut in subsidy, and this slide is covering that. So this is history now. The government has decided to cut the subsidy from 1st August to 16 pence. Now we are taking for Solas report, we have created a sample case study. So we're taking, for example, meteorological data for Annan and Dumfries. So we are showing in what manner is the NASA website producing or releasing the data. So you have the location parameters, the latitude, longitude, and other weather, general weather parameter, the average temperature in the whole year, and so on. And then you have month by month, you got the global and diffuse radiation, which is the most important thing. You also have the temperature, average temperature, and then you have the wind speed and the humidity and other parameters. They are all reported. And the good news is this data is available absolutely free. Using this data, as I showed in the earlier flow diagram, you will be able to then, if you have access to either commercial software or you have made your own software, you can then produce the hourly energy output profile for your given location. But to save that kind of bother, what we have done is we have produced for a number of locations and for a number of orientations and a number of slopes. We have already produced the tables. So a parallel to this would be on a grander scale was the European Solar Radiation Atlas. But that atlas, which is available from École des Mines in Paris, it will give you very accurate figures for slope radiation on number of surfaces, but it will not give you the PV output. As I said, the PV output depends not on just on radiation, but also on the temperature. So our guide overcomes that barriers. So by way of demonstration, we are showing here the latitude, longitude for a number of locations, and then we will show how to go about interpolating for any location which doesn't fall exactly on the latitude or longitude reported here. So we are showing, for example, here for the 12 months, taking into account the principal location, and the principal locations were these locations here. So we are showing here, with respect to the principal location, what are the parameters of the module. So the module, for example, in this column is facing south. 180 degrees means south, because north is 0, east is 90, west is 270. And the module is tilted at an angle of 40 degrees. Okay. Then we are comparing our results with the energy saving trust guide just to cross check, and we found a close validity between the two sources. Then we have produced the delivered energy in kilowatt hour per 240 watt module. So we've taken the 240 watt module as a standard module. If you have a module which is, let's say, 180 watt, only by proportion you will be able to work out what will be your outputs. So it doesn't take a PhD to do that. So we have produced here, as I say, for a combination of orientations. For example, the orientation 180 degrees, so facing due south, and at various slopes, we have produced what will be the output for these locations here. Okay. And likewise for other locations. So the guide will give you all these tables for a combination of slope and orientation. Then next, what we have developed is factors. If your module is in a location which is not exactly in the grid we have produced, or your slope of the module and your orientation is different from what given here, you can interpolate between these combinations and get your own factors. And then these factors are applied to the monthly energy yield for the principal locations. That is the philosophy of this guide. So all that information is in a number of tables. There were, I believe, 20 or so tables in the guide. So there's no point me showing you table upon table. They just have numbers. It's more important to understand the philosophy of these tables. So the guide contains a large number of tables. Next, I'd like to come back to this point of the pricing. I believe that the housing associations or private individuals or commercial organizations, they should stop looking up to the government for help. They should devise their own methods and innovation to bring into the PV, as I believe Solas is currently engaged in, and I must congratulate them on such success. The way forward, I believe, is that looking at what the Germans have been doing, the Germans now have something of the order of 21 gigawatt of PV installed in their country. And on a clear day, they can generate 1/3 of their electricity from solar PV alone. The wind is on top of this. So if we move aggressively and looking at the price structure as I was showing, that the rates are coming down all the time. So he is saying under the proposal only 90% of the electricity produced by photovoltaic installation would receive a FIT. So all governments are moving towards reduction of FIT, the feed-in tariff. But the drop in price is offering a very good chance to us. So how can we dip into this market? I believe energy cooperatives, through perhaps the housing associations, if you buy 1 megawatt of modules compared to a few kilowatts, you get a very, very good price deal from the large manufacturers. So I believe housing associations should make a club and buy in bulk. So if they were to buy, say, 100 megawatt, they'll get an absolutely fantastic pricing structure. And that's the way forward. So here a KPMG report is saying, along the lines I've been talking about, that despite the lack of investment by governments, the solar PV is marching along. This is what the KPMG report is talking about here. Another thing to look for is the introduction of electric cars. The automobile market is such a big economic sector. So if you see here, the report is very buoyant report saying Americans are buying cars again, and that could drive a real recovery. So people are counting on production and sale of automobiles. But why not we invest more on electric cars? I'm happy to say that at Napier, we have installed 3 charging points, fast charging points at 3 campuses, and we are now also investing in an electric car. Scottish government has provided money for installation of electric charging points and also for buying electric cars. So if the solar energy is brought in appropriate measure on buildings, and that could charge the cars, this could be a growth of a very serious economy in 2 ways, the PV and also the cars themselves. And that could be a very, very positive step for the economic recovery. Another thing could be the solar thermal applications, which we haven't touched upon, but that's also a very big market. As we know, 50% of the energy used in UK is used for heating of buildings, heating and lighting of buildings, and big chunk of that is for water heating. So I think Solas has been engaged in solar thermal also, and again, if you buy in bulk, you can get very good deals for solar thermal, as these slides are showing you. I was talking earlier on about the German PV capacity now. So it's now more than 20 gigawatt, and on a sunny day, they are reporting that they can produce up to they're talking about here on Friday, May 19 this year, during daily peak hours, more than 20 gigawatt of PV was injected into the national power grid, which is 1/3 of country's electricity demand. Just imagine, a northern European country, and it's producing 1/3 of its energy on a sunny day from PV means. I think we need to do more in UK and promote through housing associations and organizations such as Solas to bring PV into play, as Germans have demonstrated. Thank you very much.
Thank you very much, Tariq and Graham. And now we have time for questions from our online audience. So let's see the questions that have arrived so far. First of all, there is a question from Stephen Featherstone of Churchill Flooring. It seems that you, Solas, are directing most of your energy towards retrofit. To what degree are you interested in new build? Who would benefit from this type of equipment as part of its initial build?
Yeah, thanks, Stephen, for the question. I'm leaning forward, as you can probably see, because my eyesight's so bad I can't read the laptop right in front of me. That's correct. We are targeting particularly the retrofit market, as you rightly say. But I mean, obviously, the answer is yes. We are interested in the new builds market, and as I say, it's interesting to me that As Tariq said there, and you might agree, Stephen, that that we really do need to look to use mechanisms that are available to us to kickstart or bring into play, as Tariq said, the whole concept of solar PV. To give an example, and I won't name any names here, but I'm fortunate enough to have, well, questionably fortunate enough to have just bought a new home in Scotland from a national house builder. And if I tell you that they had not heard of solar PV, and I mean that quite genuinely, when I spoke with the person involved in selling us the house, they did not know what photovoltaics was or were, is quite concerning. And I reckon that that's something that maybe others who are participating today have come across. If a national house builder's sales representative has not heard of solar PV, then I think that probably indicates where we're at in the market.
Thank you. There is a question from Dave Tramelin of Conservation Joinery Services. If you know, what is the name of the English organization that is the equivalent of Solas in Scotland?
Okay, I saw that question coming in, Dave. Thanks for that. I mean, I'm stumped here because there's no equivalent as such that I'm aware of. However, there will be, I'm sure, well, of course, there are many social enterprises operating across the world, including England. Solas, by the way, has been doing some work in England recently, not in the solar PV market, I hasten to add. But I'm happy to discuss with you offline, Dave, and more than happy to look to see if we can put you in contact if that's what you're looking to do. But no, there's no sister organisation of Solas in England, for example. I don't know if you're able to give a wee bit more detail in terms of what you're looking to do, but you can do that online now, and we'll try and respond a bit better. Alternatively, if you want to give me a shout, you know, between the two of us, I can try and put you in contact with some organisation that will be a social enterprise with a corresponding capabilities as Solas. I hope that helps.
There is a question from Anne West of Fleming Muir Architects, and it is really to clarify something that probably you have explained during your presentation, Tariq, but still, let's clarify. Are there not edge technology PVs, which in effect is a parallel installation, avoiding to some extent the disadvantage of serious connection?
There is a trend by manufacturers. The manufacturers are fully aware of the shortcomings of the shading problems. So there is a trend towards a multi-diode module. So in one panel, they will have parallel connections. So they will not connect all the cells in series, but there will be so many cells which will be controlled by the one diode. You follow?
Yes.
So if one row of, within a module, if one row of cells are shaded, it will not affect the entire panel. So there is an attempt, but the cost will obviously rise because you'll have more diodes. So the manufacturers are fully aware and they are reacting to it.
Thank you.
But it will take time.
Thank you.
To change the production machinery and all that.
We have a question from Linda Sheridan, who is an independent consultant, and she's asking, what is the optimum tilt angle? I have seen varying amounts for the angle to deduct from the latitude. Are there estimates of the impact of North Sea mists on PV production, which often occurs when it is hot and sunny further inland? In the Lothian, this is known as har.
Sea har, yeah. Well, there are in effect two questions there. So the first one, optimum angle. In general terms, there is a rule of thumb that if you take the latitude of the location, so take Edinburgh, its latitude is 56 degrees north. You would multiply 56 with 0.9 and you get number 45. So if you tilt the angle at 45 degrees, that's the best angle. this rule was developed not by me, by University of Wisconsin, and it's been tested worldwide, and all the time it's getting proved. And we have also tested it and found it to be true for UK locations. So 45-degree angle for Scotland in general terms will be quite a mainland Scotland, not Shetlands. So 0.9 time latitude, that's the rule. And it seems to, fulfill its predictability is very, very validated, that it will give the maximum power. The second question about CHAR. Yes, I have noticed sifting through a lot of data which I use for the production of solar guides for organizations as simply Chartered Institute Building Services Engineers, CIBSE. If anybody interested, they can go on the website. They are the definitive organization who produce data sets for UK locations. Now, what you will find is for the east coast of Scotland, the mornings are mostly sunny, and then the cloud seems to drift from the west. So for such locations, you may want to run the simulation program I was talking about and find out what is the best location, optimum orientation and so on. Because you may find not south, but slightly east of south may be the best orientation because the mornings are, sunny. So in that case, you may want to run the program through the whole year and establish yourself there.
Okay.
So there could be some local climatological effects.
Thank you. Question from Sean Hutchinson of M Design UK Ltd. Does advertising need to be adopted with a real clear benefits to encourage PV installation?
So sorry, could you repeat that again?
Does advertising need to be adopted or encouraged with real clear benefits to encourage PV installation?
Yes, I believe the industry has come about in a very, hodgepodge kind of way. There's not been a systematic, for example, for plumbing jobs, there's an Institute of Plumbing. There's no Institute of Solar Manufacture, you follow me?
Yes.
So there need to be more legislation brought about by government perhaps to make this an authentic kind of club. There will be, I'm sure, Association of Solar Installers, but it is just an association rather than it has a stamp of approval by authorities. Perhaps that should be brought into play. And then if they advertise, it will be genuine and also effective. So I agree with this gentleman that there should be, yeah. So.
Sean, it's an interesting and quite open question. One thing you might be able to help Solas with, if you're in any way interested in what we're trying to do here in terms of social economy and kickstart solar PV in Scotland, is you might have noticed that we've taken a chance and done some national advertising in press and other media, and whether you've seen that or not, certainly if you are interested, I would welcome your feedback on what you think. If you've not seen it, let me know and I'll send some of the stuff to you, because genuinely, and that you've asked a question, I would welcome your feedback. What we've tried to do is come at it from a different angle than the sorts of stuff that you might more generally see in the back pages of the Sunday Mail, for example, in amongst the double glazing sort of pounds, save, we won't be beaten on price type adverts, which is one way of marketing your products. We've tried to come at it and demonstrate the sorts of stuff that we've spoken about today in terms of Solas status and the sort of trusted intermediary type approach. I would welcome your feedback, so if you want to give me a shout, I really genuinely would welcome that. The other thing to touch on what Professor Muneer has said is that, yeah, maybe there is. I know that obviously the Energy Saving Trust has information on solar PV and other renewables on its website. Maybe with some representative organisations, we work very closely with the Scottish Federation of Housing Associations, the Institute of Housing. An element of working with the Scottish Government too is that whole concept of getting together through trusted bodies and bringing the public perception and understanding more up to speed, because generally at this stage I would suggest that it appears to have been left to installers in particular, to, including Solas, to contact or make inroads into the marketplace and try to sell, as it were. It may be that there's an educational concept in terms of marketing, which maybe that's what you're getting at, and I certainly would absolutely support that. Because our feeling, as I said earlier, is that the confidence has been ripped out of the marketplace, and confidence is something that DEC and Ofgem are speaking about in relation to solar PV in particular. We need to work together to re-inject the confidence. There's been a knee-jerk, for good reason, across the whole marketplace, and organisations and individuals. We need to work together to re-inject that confidence, and the way that you're suggesting there, Sean, I would imagine would be an excellent way of doing that.
A question from Brian Spencer of Lothian Solar. What are Professor Muneer's thoughts on future developments on storing PV electricity, such as diverting excess production to domestic hot water?
Well, see, okay, both are the thermal or the electricity, they are both various two forms of energy. But the solar electricity or electricity in general is a very high grade energy. I wouldn't want to save electricity as hot water, because to reverse the process, it will be very, very low efficiency. So if anything, we should store in batteries. And I'm happy to let you know that just yesterday we have received a batch of batteries from California company who are using graphene technology to reduce the battery cost by 70%. And we have actually got the product with us. And over the next few months, we are going to test this battery to take it to destruction, to see how many cycles it can charge and discharge. If the battery cost can be genuinely reduced by 70%, I think that's the way forward, rather than storing, electricity in hot water. So I would just store it as electricity, and then I can draw it back when I need it at night or whenever,
Thank you. A question from Bruce Newlands of Craft Architecture. Should subsidy feed-in tariff be targeted specifically at social landlords for larger arrays and vulnerable tenants, rather than free for all? It seems to have been abused, and this appears to have led directly to the recent feed-in tariff cuts.
Yeah. If you don't mind, Branka, I'll say a few words.
Yes, no, it's your area.
In short, yes, is the answer. I believe so. And I believe that in response to the recent consultation on feed-in tariffs and various changes, that there are some moves to offer. There's been some suggestion about enhanced feed-in tariffs for social landlords. The housing association movement has traditionally helped pave the way for emerging markets, in my experience and knowledge, which isn't brilliant, over the last 20 or 30 years, and working with a number of housing associations, as you possibly do yourself, Bruce, there is an appetite to stretch the boundaries and do stuff. Again, it's back to there is an element of confidence there, but yes, I totally agree that there should be, and I believe that there will come, if they're not already there, special rates available to housing associations, so that we can use that model and mechanism to demonstrate what can be done. And as we will continue to work with our clients in that sector, and the Scottish Federation of Housing Associations, and the Scottish Government and other key stakeholders to try and push that one forward. As I mentioned earlier, there is an exciting development coming, which is heavily linked to what we've spoken about today, which Solas is involved in. And if you watch this space, I'm touching wood here, that this will come out and be public, and it's quite exciting as Tariq and Branka know, in terms of a precursor for what we really genuinely hope will kickstart in terms of the market and housing associations and community benefit and solar PV. But in short, the answer is yes.
An interesting question from Dipanita Das, a technical question. She is a freelance architect. I would like to know, what is maximum land slope that can be considered while placing photovoltaic modules?
I think we covered the slope. And
but this is a length slope. My understanding is if we would like to put a PV photovoltaics on a hill.
Yeah, it's the same slope. The slope is slope, no matter where you put it.
So even if we have a hill of 60 degrees, we would try to tilt the PV to be 45 degrees.
Yeah, because you are not going to just go and stick it on the hill, are you? You're going to have a framework.
Yeah.
You know, you will have a matrix of a metal matrix of sort. Then to change it to 45 degrees is not a problem really, because it will be part of the design as such, you know.
There is one additional comment from Bruce Newlands of Craft Architecture. Interesting to hear about the 45-degree optimization. Perhaps greater emphasis should be made on the other benefits of that angle, principally a room in the roof. A higher density occupation between 40 to 45 degrees is also a very traditional pitch in Scotland. Perhaps integrated photovoltaics at these angles can also contribute to the placemaking agenda.
Yeah, I totally agree. Yeah.
Okay.
It's also good for the snow loading, avoiding snow loading.
Yeah.
Because, you know, if it's less shallow slope, the snow will stick around more.
Yeah.
But 45 will fall off earlier.
A comment from Stephen Featherstone of Churchill Flooring again. Thank you for your earlier reply. I would like to see this type of technology included as a requirement for planning permission. This would compel improved fuel efficiency to be included in the building of properties on both a domestic and commercial level. Some of the costs would then also be included as part of the building cost and would not have such a big impact on the individual for one large cost associated with adding PV at a later date. The government needs to get this type and other types of technology included in the building program.
Yes, I agree. We have to bring this into play by using a number of factors, and one of that could be what this gentleman is saying, yeah.
Additional question from Sean Hutchinson of M Design UK Ltd. He said, first, thank you, and I would like to see it. Another question, could feed-in tariffs be means tested?
I've just been following the questions coming in there, Branka, and I reckon that might be a response to the question that Bruce had asked about targeting of funding specifically at social landlords. Might not be, but yes. I'm guessing that's what it is. Could feed-in tariffs be means tested? Yes. Is that a way of targeting scarce resources at trying to deliver community benefit to those who may benefit most? Yes. So in short, absolutely, that's something that I dare say the Westminster government would have to take on, and I dare say it's something that has been fed to them as part of the recent consultation. Obviously, the Holyrood government will have a major part to play in influencing any decisions along those lines. But absolutely, it's certainly a concept that could be explored.
Yeah, I agree. It should be explored, perhaps.
We also have a comment from Anne West of Fleming Mew Architect. Education is as important as advertising. We have had planning refused for new build on an island with limited fuel sources and fuel poverty issues due to the appearance of photovoltaics. Having dealt with orientation to maximize load, upped thermal performance to decrease energy input, it is going to find that the local authority does not place the same degree of importance on these issues. So, an experience that is shared with us today. We have a bit more time, and maybe some other online viewers will send additional questions, but I have a few questions as well. Graham, you mentioned that you have installed insulation on around 150,000 homes already. So could you say that there are skills available in this area, or is more skilled force needed to do more as we go ahead with more insulation? What is your assessment of the current situation of skills available in this area?
I'm not an, there are better people than me to answer that question, but I can only give my own personal understanding and view. The changes in the retrofit insulation market that will be brought about by the Emerging Green Deal and Energy Company Obligation will introduce an emphasis, as far as I can pick up, on technologies on insulation that have not predominantly been a part in the market to date. That opens up opportunities, and particularly I'm talking here about things like the move away from cavity wall and loft insulation is such a major part to things like solid wall insulation, which from a Scottish perspective, and particularly, well, actually across both urban and rural Scotland, the need for solid wall insulation and good solutions is there. But with that comes the opportunity to create the skills within the construction sector and the capacity to deliver on that. And there is a question mark across the UK. We are working very hard at Solas to protect our current workforce, and we exist actually, as you know, to create and sustain employment and to train people. And I can tell you that, needless to say, we're heavily involved in looking at the medium to long term future for my colleagues at Solas and training them in that regard. So you know, there are major challenges, you know, to take someone that's involved, for example, in cavity wall insulation, which is a semi-skilled job. There are replicable skills involved, but when you're talking about working within someone's property on internal insulation, for example, as you might imagine, there are different skills involved in that, more along the lines of joiners and electricians, and we're working hard at Solas, and I know there are many in the industry that are doing that. In terms of the opportunities for work creation in terms of solar PV, again, yes, obviously there's been major impact because of the feed-in tariff changes that came about October, November across the whole industry. But we at Solas and many others, no doubt, will be taking a balanced approach. We try to diversify in a way that our workforce is flexible and can do more than one thing, and we offer a range of different services. So it's very, very tricky to try to get a situation where you can create and sustain employment within the market. It's easy when you say it quick enough, but not that easy when you're trying to do it. But touch wood, we continue to work hard to protect our current workforce and to create new opportunities. There's a lot of training and a lot of transferring of skills and development of people involved in that process, and it takes time.
I'd like to add to that. It's a very good question, actually, that one, because it hits on the nail on the head. How do we transform this economy to solar economy, let's say? You know, a lot of people have talked about a solar Marshall Plan for Europe or for UK, just to take the bull by its horns and sort it out. And in this respect, I'd like to refer to a very interesting book by Christian Woolmar. He's a railway historian, very famous one. He produced a number of programs for BBC. If you go to BBC bookshop, you'll find his books and videos and so on. He says that in 1880s, when Britain started the railway program, it was like a Marshall Plan. In 7 years, Britain installed 90% of the rail network, which we have now. 90% of what we have now was done in those 7 years in 1880. So I believe if we have a solar PV Marshall Plan or renewable energy PV plan, let's say, a combination of wind turbines and solar PV and solar thermal, there are a very good network of further education colleges we have. In Edinburgh, we got 3, which have 30,000 students in them. Telford, Stevenson, and Dewlenesque. These 3 colleges, they're now getting merged. The similar moves in Glasgow, I understand. Now, with that kind of staff and that kind of intake they can take, they can convert people with no skills into good skills for PV installation, PV inverters, selection, purchasing, every kind of level of training can be provided. I'm very sure of it. And the university can provide the higher end backup. Then in less than 10 years, this entire country can run on 100% renewable. I'm not saying that lightly. It is achievable with the battery storage that I was talking about. So you bring solar thermal, solar lighting, solar electricity, electric cars, wind turbines on a community shared basis, not on rooftops. And you bring the storage also in it. And you can convert the entire country in 10 years to renewable energy.
Yeah.
And you need to have the workforce, of course you have. But people like Solas can contribute towards that. Yeah. The further education colleges can contribute, the universities can contribute. It can be done.
And the master plan and a number of the questions have come in today. I talk about a sort of that strategic joined up approach. We've had a chat about planning permission. We've talked about government investment, we've talked about feed-in tariff, we've talked about Westminster and Holyrood, and really it's back to this whole concept of Scotland being a world leader. We've spoken about social enterprise, we've spoken about community ownership. You know, that is our vision at Solas, you know, and there's a huge, it's fantastic to hear Tariq saying that in 10 years we can achieve that.
I'm absolutely, if it can be done in 1880s, in 7 years, 90% of the network was set, and in 10 years the remaining 100 years to 10, because they were niche markets. Then why can't we do it now? We can definitely do it.
Thank you. Here is an interesting comment from Dave Tremlin, who was asking for your contact details, but also he says, in the event of England not actually having a Solas equivalent, could the Scottish Parliament please consider annexing England and giving it the same support for its move for energy efficiency as it gives its own domestic market? Solas is a benchmark. Thank you, Dave Tremlin, for this comment. But we do not have any more questions now from our, here is one from online audience. We still have a few minutes to go, so let's see. From Dipaneta Das, with reference to the land slope question, I understand that the spacing between modules has to be increased if we place it on steep slopes to avoid shading issues. For the same land area, the land in a flat terrain will be preferred over one in a hilly terrain for laying PV modules. Is my understanding correct?
Yeah, see, there's no one rule, because he's right that the more spacing the better. But then you're not optimizing the land area available or the roof area available. So you have to strike a balance. So I refer this gentleman to a book, very interesting book called Energy from the Deserts. And in that book, the Japanese researchers, they have come to an optimum spacing. So they look into how much time a module will be in shade compared to how much is the land area available. You follow me? There are two opposite ends. And that book tackled this problem head on. So I refer to him. Or if you cannot get hold of the book, then in one of our articles, we have incorporated that. And I'm quite happy to send him that article if he sends us an email. Or send you an email.
We have contact details.
Then we can send him.
Yes, we can send an email with the reference.
Yeah.
We do not have any more questions, and we are also close to 2 o'clock. So I would first of all like to thank both Graham and Tariq for presentations, to thank our online viewers for their questions, and also to draw attention of our online viewers to our next webinar, whose title is Assessment on the Choice of a Renewable Energy Source for RETEC. This webinar will take place on 20th June. The speaker will be Julio Bros-Williams of Edinburgh Napier University, and also we will have Kevin Callaghan of RETEC. I would like to thank you for watching today's webinar, and we look forward